This gives me 1. And you can see that it's actually right there, the y-intercept, right? Because you put in 0. All of these are going to go through 1, unless we move them, but we're going to go through 0, 1, because anything raised to the 0 will be 1. So it doesn't matter what base I use, it's still going to be 1 right here. So this is kind of an important spot. And if you look at it, it really is, and this is not the correct term, so don't use this term, but it does kind of look like the vertex of like a parabola, like right where it turns. It is an important spot. It's not called a vertex, but it looks like one. So it's something that we can watch move though. And of course, when we put 1 in, we get 3 to the first power, which is just 3. And you can see when you put in the number 1 right here, there's 1, 2, 3 in our graph. It's a pretty common point. And then when you put in 2, you get 3 squared, which is 9, and you can see at 2, we're already up here at 9. And then when you put in 3, 3 to the third is 27, and it's already at 3, it's already way off the page, and by the time I get out to 10 or 11 or 12 or 15, this thing's gonna be up in the cloud somewhere. You see what I mean?
What is this for?
What is exponential for?
Well, I know the exponential form. Like, what unit is this? What are we?
It's for homework number 9.
Okay,
It's
thank
the
you.
very first questions of homework, and we're gonna be moving this thing around. So what we're doing is we're learning a little bit about the exponential graph, because this is a very famous graph, actually. I mean, many people model lots of things with this. Like I said before, the 5-second rule is a pretty famous one, right? You get about 5 seconds. Because as bacteria grows quickly, after 5 seconds, where is this gonna be? Too many bacteria. That's kind of just, I guess, a good reference. But lots of things grow exponentially. And it's true in the world that a lot of plants and mostly populations grow exponentially. That means they grow pretty quickly, like this way. I mean, if you could see something like this, if this was, hundreds of dollars, if I could put in an investment for, $100 or something and watch it grow like this, after the end of the month, I could probably retire. That's the kind of speed we're talking here. So wish that was the case. Mine is actually going this way. But anyways, but this is just a very, very basic example of what an exponential function looks like. Now, there's a couple of things here that are also important. As we get into the negatives here, it looks like it's eventually going to become 0, but remember, as we go down in the negatives, like -2 would give me 3 to the -2, which would be 1 over 9, 3 squared, and then -3 would be 1 over 27, and -4 would be 1 over 81, and these numbers are getting smaller and smaller and smaller as we get into the negatives deeper and deeper and deeper, but they never get to 0. So this particular graph is just riding right along that x-axis and coming in basically like a landing, like an airplane does, right? This way, it's coming in for a landing, but it never actually touches 0. So this is called an asymptote. Really weird word, isn't it? That's how you spell it. asymptote, asymptote. They call that. That's what the x-axis is, an asymptote right here.
Asymptote.
Yeah, that's it. Asymptote. I never have pronounced that word correctly. Asymptote. I call it asymptote.
I'm a math teacher, not an English teacher.
There you go. Exactly. Known what it is for a long time, just can never really pronounce it correctly.
It's fine, just letting everyone know.
Thank you. But the thing is, remember how when we had our, I'll do this right here one more time, a times x minus h squared plus k. Remember doing this with the square, and we did what? The inside here, what was it you coined it? I want to steal it from you. The inside lies, right? And then the outside goes up and down like this, and then negative here did what? Flipped it over the x-axis, and the negative on the inside, flipped it over the y-axis. Well, we have the same idea with this one, except that the parentheses are now up here on the exponent. The k is still out front, although sometimes they'll write it like this. That's supposed to be k, plus a to the x minus h, which is silly because, we're used to the k being in the back, right? Sometimes they'll put the k in the front on this one just to mess with you. But that's just the same thing in plus, right? You could just take this and turn it right around. So don't be drawn off by them putting the number up in the front, because sometimes they do that. And I guess it's just to keep you on your toes. But let's see how some of these things move and what it means to move, because if you looked here in the negatives, if I was to slide this thing over in the negatives a little bit, you wouldn't be able to tell the difference because it's already so small, right? But right here, this point where it goes through the y-axis, if I move it over, it'll be clearly moved over. So this is also a good spot to look at to see when we're moving it. What do I mean by move? Well, if I put inside the parentheses here, let me stick with 3 to the x, I'll do 3 raised to the parentheses x minus, let's do 4. Okay, so there's 3 to the x minus 4. Now notice that, it's hard to see, I know, it's tiny, but that's now raised to the x minus 4. In other words, I put a 4 right here inside the parentheses, and we know inside the parentheses does what? Back and forth. And as we quoted, it lies, right? So which way should this thing move when I put it on there?
Right.
It's going to go to the right, because remember, inside the parentheses, left and right. Okay, so it should move to the right by 4 units. Well, let's see what it means by move. See how it moved over? But this part here still looks the same, right? If you look at that. What moved really is this part. See how that's the part that you can see. Of course, you can kind of see here too that that's 4 apart, but eventually, you know, if we go far enough out here and we could back way out from the graph, these two things will actually join together. Because at some point, infinity is just infinity, right? And they're both getting so fast that if we back way out from the graph, this won't be noticeable anymore. This is going to go like this eventually. And this part's the most noticeable movement right here. Okay. Now, one other thing too that is noticeable here, that when I have 3 to the x minus 4, I could put plus 0, right? I mean, that would be silly to do, because why would you put plus 0? But I could, right, because it's still the same. And what is the equation of the asymptote here, or the equation of the x-axis in this case? Y equals to 0, right? That's the equation of the x-axis. Notice that this is a 0 is not an accident, that this k is also always the asymptote. So if I was to stick another, I don't know, what do you want to pick a number? 4. Yeah, well, I already used 4, but I'll do it again. Yeah, I did say pick one. Okay, so let me see if we can get this to work here. Plus 4. Okay, so now if I do that, then you see how the whole thing lifted up in the sky by 4? It's the same as this, this one right here, actually. This one's been moved over by 4 this way. See the minus 4 in the I guess what you would call the parentheses, right? I know there's no parentheses there, but you just have to imagine they're there. And then the plus 4 raised it up, so it went over this way and up 4. And what you can really see moved was this original point right here, the y-intercept. It went over 1, 2, 3, 4, and then went up, well, 1, 2, 3, 4, about right there. I guess it would be even with that, yeah. So you can see, I know it's hard to see with this pen, these green dots are not noticeable, but this is what's moved, right? You see the sort of vertex looking thing. It's not really a vertex, so don't say that anywhere else. But it's like one, right? Because on a parabola, let me get a better pen. On a parabola, we have the part that comes down right here. This is called the vertex. And that is a vertex. And this thing right here, we have this point right here, which kind of sort of defines both directions that way. So it kind of looks like a vertex, but it's not. It's just the y-intercept. But that's what we moved here, and then we moved up here to get this new one by doing 3 to the x minus 4 plus 4. So that minus moved us into the positive, because remember the inside lies. Now, it is common to put parentheses around there to make sure you know the whole thing's an exponent, but obviously you can also do it without it, right? But just imagine there's parentheses on there. And then of course the outside doesn't lie, it does what it's supposed to do. What do you think happens if I put a negative out front?
Flips.
Flips over the x-axis, right? The whole thing. Okay. So let me get rid of some of these other ones here. We'll go back to the original. This is just 3 to the x. And I'm only picking on 3 to the x to pick on one, right? This works for anything raised to the x. Okay. So if I was to put a negative out front here, let me just get rid of all these. Not that. Wish I could operate a computer. Okay, so let's just do minus 3 to the x. So what's that gonna look like? Well, exactly like you think, it's just gonna flip it upside down. You see how I did that? Of course, it didn't change the asymptote, right? Oh, you can't see it, but writing all over it. It didn't change the asymptote at all though, because we still, even though it's just not -3 here, there's still a +0, which we don't write. But if we did, you would see the +0 right here. You see when we moved it up 4, the new asymptote became 4? So always the asymptote will be equal to K. And I can move this up or down as much as I wanted to, just like the other one. But what do you think would happen if I put the negative up here? What happens if we put the negative inside the parentheses?
Flip over the Y.
Flips over the Y. So if I do that here, I can make this thing flip over the Y too. And let me do that. Maybe. Get this computer to do anything. Why won't you do that? Divide you. Okay, so 3 raised to the negative x. Okay, now the negative is in the inside. I could put raised to the -x -0, but I'm not gonna write -0, so it's not gonna move back and forth. It's just gonna be the same one, but it's gonna flip around the x-axis like that. Y-axis, excuse me, the y-axis. And notice how I just took this red one and just what? Flipped it right over the y-axis like that. Now, this is interesting though, because this actually shows you both what we really want to study a little bit here is this red one is exponential growth, and this blue one is called exponential, does anybody know?
Decay.
Exponential decay. Lots of things decay exponentially. Probably one of the most obvious ones is if you take painkillers, right? You know, the painkillers, like, they kick in, and then they slowly start to wear off. They don't just wear right off. In other words, you take a painkiller, it doesn't just go shoot straight down. The effects wear off exponentially, and then finally they kind of stay in your system a lot longer at very low levels before they eventually just go away.
Radioactivity decays exponentially also.
What's that?
Radioactivity decays
Oh,
exponentially.
radioactivity is one of the most ones we use the most, right? For, well, that and for example, that every living thing has carbon inside it, right? You have all of your carbon. As soon as you stop living, your carbon starts to decay radioactively. And next thing you know, after thousands of years, your carbon will finally just go away. But they can use that to go backwards and see how long it took to get where you were. And we'll talk about that. And anyways, there's lots of different examples of exponential decay. But more importantly, right now, today, take a look at homework 9. The very first page has this sort of matching of graphs. What we're going to do is we're going to take the graphs, and I notice they're using 4 to the x, okay? I was using 3 to the x, and if you look at the original one, 4 to the x right here, it looks exactly the same, right? The asymptote's right at 0, comes through 0, 1, and shoots straight up like that. It doesn't look hardly different than 3 to the x. So it's, 3 to the x, 5 to the x, whatever I wanted to use, it's all gonna look pretty much the same as this. So this is definitely the original one, so that would be where's that one right there, y equals 4 to the x. So I need to grab that one and I need to put it right here. So it's kind of a matching thing. There's 2 of these actually on the homework. So this one is clearly the first one right there. See that? Now we gotta figure out the other ones though, okay? So if you take a look at this one, notice that the asymptote is still at 0, so that means none of these numbers being added either in front or the back, right? Because 0 is the asymptote is decay. So it's gonna be one of these, and it's flipped over what? What axis is this flipped over?
Yes.
Is that, where does the negative go to make it flip over the x? In the front, right? Not up in here, but this one right there. You see what I mean? Because the minus is in the front, and the minus in the front makes it do what? Flip over the x-axis. So this one right here needs to go in here. Okay. Now if we look at this one looks an awful lot like the original, but the asymptote now is what? You read that?
Is it x minus 1?
Yeah, -1.
Minus 1?
So we'd have to have a -1, right? Like that one. Does that make sense? Where the -1 is the new asymptote down here? Because the -1 is the asymptote. Are you sure you understand this? Okay, so that one goes right in here.
It did.
Oh, no. Okay, so if you compare the original one here, starts off with exponential growth, this is exponential what? Decay, and it goes right through 0, 1, so we know it hasn't moved, and it's still got the asymptote of 0, so what's the equation of this one? 4 to the minus x, or that one. Make sense? The minus sign flipped it over the y-axis. You try to break it? All right, so this one, this is exponential growth, but notice that it doesn't go through 0, 1, it now goes through 1, 1. In other words, it's moved into the positives by 1. How do you do that? Well, you put that in the what? Right up in here. So it should say x minus 1 right here. So there's the one that does that right there. See it? So that one is going to be here. Now, if you take a look at this one, it's flipped. First of all, it flipped over the y and then over the x. So there'd have to be a negative in the top and in the front. Kind of like that one, right? Okay. So you guys are catching on again. All right, now, oh, whoops, I dropped it. Get in there, okay. Now, the other thing I can do here is, you can see the asymptote here is 0, right? So it has to be this one, and I'll explain why in a second. There's decay is 0 on that one, right? See how this is 0 right here? So it has to be a +0, which this one has. This one has what? Not a +0, but a +1. So this is clearly going to be this one, where we have a 1 for the asymptote. So that's why that works. But what's going on with this one is interesting, because what they you know, they always try to hide stuff from you. That's their goal, okay, to confuse you. Y to the 1 minus x can also be written as, or 4, not y, as minus x plus 1. See how I do the minus to the x, it give me minus x, and minus 2, y, 2 negatives make the positive. Now you can see it's flipped over the what? Y-axis and moved into the positives by 1. But they wrote it this way to confuse you. Does that make sense? So they just played with the algebra there. Okay, so, and the last one I think is pretty clearly, that's the best thing about matching, right? You get the last one for free. You can't go nowhere else, right? So it must be this one, which it is. All right, just get it to stay in there. There we go, I'll check our answers. Awesome. So there's 2 of those for you to do, so you can have practice. See, the next question is exactly the same. They usually don't have the same base. I got 4 to the x for both of mine, but you won't. You'll get like 3 to the x and 6 to the x, or 2 to the x and 9 to the x. It will be different, you know, but there won't be any different as far as moving around. So I'll let you guys play with that one. And let's just go ahead and graph a couple of these using the regular graphing technique here. Okay, so if I hit my graph and I look down here, this is the square function, right, the u. This is the s function. What's that one again? Cubed, right? And then we have this one right here, which is actually a logarithm. We haven't done anything with that yet. And then we have this one that looks like an exponential growth. See it? Because we always start with that one when we have exponentials. So it's going to be this one right here. And all you do is you just tap on it and grab it, put it anywhere you want to. It doesn't matter because it pulls up that box. And it used to make you change the base. I know this is a new thing. This last couple semesters, they've made it easier on you. students, excuse me, notice that the base is already 2. They used to make you actually write that, and now it just comes popping in. I guess it was making people angry or something, I don't know. But you don't have to write the base. This is the base right here. But you do have to do the same thing we did before. So you go up here to the exponents. What's the exponent up there being negative? What's that going to do?
Flip it over to the y.
Flip it over to the y. So we're going to use, I know it's hard to read, that's the y one, right? It says y-axis there, reflection over the y. I know it's very difficult to read, but this says reflection over x, this is reflection over y. Can you guys read that?
No.
Nope.
Yeah, I can't either. Okay, so just trust me, you can see the y and the x though right here, maybe if you look closely. You can see it on your own computer. I'm gonna choose the y one because of that. Now, what else has happened besides this? What's that -4 do?
Down.
So is that vertical or horizontal?
Perfect.
Vertical, so the vertical goes to -4 and it's flipped over the y-axis and that's the only thing that's changed. The base is still 2, which you don't have to write more. Yeah, I used to like to make people write it because it makes you see what base is, but apparently Pearson got enough calls on that one that they've now just filled it in for you. So reflection over the y-axis here and then vertical shift down by 4. How come I'm going down by 4? Because the outside doesn't lie. I like that answer, by the way. I think it's going to ask me for the domain, right? What is the domain of the exponential function? Well, it's minus infinity, infinity, because there's not a number we can't put in there. There's no division by 0 going on in this thing at all, right? There's no division happening anywhere. So we're not dividing by 0, we're not taking the square roots of negative numbers. So when you see no square root symbols or no division, is always what? Minus infinity to infinity. Now the range, on the other hand, the range for this particular one goes down as low as what? -4 and up? Does it ever actually hit -4 though?
No.
No, it comes in on like a landing strip but never hits it. So do I use a parenthesis or a bracket at -4? Parenthesis, right? Because bracket would mean I would be able to use it. And it goes from there, it goes up as high as you want to, right? But nothing down here any more than -4. So it's from -4 all the way up to infinity. And with a parenthesis because it can never actually hit there. So what I'll do is I'll just paste in what I got there before, but I'll go change that to a -4 instead of an infinity sign. I should be good. I copied and pasted the first one, or copied it onto the clipboard. So the next couple questions when they ask for the domains, I could just hit paste and I don't have to parenthesis minus infinity colon infinity, well, you know, times there. I'm pretty lazy when it comes to a computer, so I do things like that. What's it say? The horizontal asymptote. It does not have 2 horizontal asymptotes. It has 1. And what's the equation of it? Y equals to what?
-4.
Always to the k value. What's the k value? Right, simple as that, every single time. Just look at the k value and you have your asymptote. Y equals though is the equation, right? See how I wrote y equals -4? Don't just write -4 in there, because it's not an equation. And I think that's it. Is there another question? Oh, the x-intercept. No, y-intercept, sorry. The y-intercept, well, when you put 0 into an equation, you get the y-intercept, right? And if you put 0 and 2 to the -0 or 2 to the 0, what's anything raised to the 0?
1.
Subtract 4. -3. So it says type an integer. It really should be 0, -3. It's a point. This is another thing where I have a little problem with what they do, but they're just making it easy on you. They just want you to type -3 here. It should be, in my mind, the point 0, -3. It's what you always do on a test. Always give the point when it comes to the intercepts. When it says, what's the y-intercept? In class, we say -3 all the time, but on a test, you would always answer 0, -3. And on the homework, you should too, but this one says not to. So if you write that in there, you're going to get it wrong. So you're doing something against what I'm telling you to do. But I can't change that. So in this case, you get away with just writing. Just make sure you read the instructions, okay? -3. there's a couple of those, we don't have to run through the whole thing, just notice that, remember I said sometimes they throw the K in front to fool you, so don't be shocked by that. Then if you just take that and make that you can take that two, take it away and put plus two, it wouldn't be any different, you see what I mean? So now you can see what's the asymptote for this one, y equals to 2. This thing opens upward, it's moved 3 units into the what? Positives. You see how it's moved 3 units into the positive and moved up 2 units, just like we know how to do from like I said, this works on all functions. But what to move though is hard to see sometimes, so that's why I say we take this point right here, which is the standard, I should learn how to draw, but this standard sort of y-intercept that goes through 0, 1 for all of them, I would move that, if I had to draw this, I would move that 1, 2, 3 into the positives for that thing right there, and then up 1, 2 for that, make my asymptote at 2 now. Here's my asymptote, and then I would just start and go right through there, like something like that. That's how I would roughly draw this thing. You see what I mean by moving that one? It's not a vertex, but it's kind of right in the middle of the term, right? So it's something you can see move. Now let's see what happens when I actually do it. We'll get this here, put this on here, and then what do we say to do? We're gonna go into the horizontals by 3, and then the vertical shift is up 2. How'd I do? Pretty good drawing? Yeah, see what I mean? So you can do that too. I just moved that one spot, and look, I almost got it perfect. And that was by a freehand too, so and I'm a terrible artist. I'm gonna take that as a win. Okay. Are you guys feeling like you can do this now?
Yes.
Okay, good. Has anybody done this homework already?
No.
Okay, so not to beat it to totally to death here, but what's the domain?
All real numbers.
Right, I noticed that I already have that on my clipboard, right? So I can just copy it right there, and then we're going to go to the range. I can copy it again. Of course, this is not minus infinity to infinity, but I already have it set up pretty close, and all I have to change is this minus infinity to what number?
2.
2, right? In other words, decay value, right? Okay, so I'm just going to put positive 2 right there. I'll get rid of this. Okay. And then what is the equation of the asymptote? Y equals to 2. Okay, just don't forget to put y equals. And what's the x-intercept, by the way, or the y-intercept? Actually, that one's going to be a little tricky.
Because it's not quite 2.
It's 2 plus a little bit more, right? So what we're going to do is we're going to put 0 in for this x. Remember, to find the y-intercept, you always put a 0 in for x. So this will be 2 plus 2 to the 0 minus 3. Putting in a 0 for the x. That becomes 2 plus 2 to the negative 3. What is 2 to the negative 3? 1 over 8. In other words, 1 over 2 to the positive 3. So this becomes 2 plus 1 over 2 to the positive 3. 2 to the third is also known as 8. So 2 plus 1 over 8. Now I have to add fractions. This is what? 16 over 8? 16 over 8 is 2, right? 16 over 8 plus 1 more over 8 is how many over 8? 17 over 8. Right? Okay. Okay. There's a couple more of those. All right, now they switched over. Instead of using what it was, 2 to the x last time, or whatever, now it says e to the x. Well, e is just a number like 2.78. So don't be shocked by seeing e. It's no different than 2 or 3. It's right. It's actually kind of in the middle of 2 and 3. So it's just another number. We're raising it to, we're using e, so the base is e. Other than that, nothing else changes. And when you pull up the graph, it's already put e in because I guess Dave Pearson has been, I don't know why they did that. I wish they didn't. But you can see when I put this on there, look, they've already got the base written as e for you. So you really don't have anything to worry about in the base anymore. don't you think you should have to fill that in?
That would help.
But anyways, it's filled in for you, and all this one does is move into the what? Positives by one, that's it. So you're just gonna take this horizontal, move it to one, and be done. It's nothing different at all about E. It's the same as doing it with threes and twos, so I won't bore you with more of that. This is the same thing. It's exactly the same thing we just did. I'm not gonna destroy that. And then we get into the new stuff. Okay, so
I love these.
what's that?
I love these.
What, these or the,
Like
or the ones we?
logarithms and stuff, like logarithms, I don't know why.
I do too. I think logs are great, but I need to teach you three very important properties, okay? There's quite a few properties of logarithms, but we're gonna focus on a total of 4 for this class, okay? 4 super important ones. Number 1. If you have the log of 2 things being multiplied, I'll call them m and n, whatever they are, they're being multiplied for the common base of a, you can write this as log base a of m plus log base a of n. In other words, if you have 2 things being multiplied along, you can break it to the sum of the logs, which is an awesome property. And its little cousin here, which is a log base a of m divided by n equals log base a of n. What do you think the sign's going to be here?
Minus.
Minus, exactly. Log base a of n. So those 2 are super famous, super popular, very useful when it comes to solving equations that have logs in them. And then number 3 here is one of the biggest reasons we use log is that if you have r times log base a of x, you can rewrite that as log base a of x raised to the r power. I started to tell you about that the other day, but you weren't quite ready to hear it yet, but now today you are. In other words, you can take this r and throw it up here or bring it out front depending on what you want to do. You can freely move the number from the front of the log and make it an exponent, or take the exponent and put it back out as a factor, which is kind of nice, and that's rare in math that you can just freely move stuff around. There's a few places, but not often, right? Usually in math, where things are is where they stay. Logarithms, you can just pick this r up and put it up there, or put it back down here, whichever one you want to do. Now the 4th one is really only useful, well, I'll let you decide. It's called the change of base formula. So in this case, if you have log base a of x, you can rewrite that as a division, log base b of x divided by log base b of a. And this is the best part, where b is any base. In other words, you can choose. It doesn't say that in the book, but it's true. Why would you want to be able to choose a base? Well, let's say you have to do log base, let's see, 5 of, let's do 30. Okay. So what's that saying to me right here is 5 raised to what power equals 30? Well, I know 5 squared is what?
25.
And 5 cubed is, and 30 is closer to 25 than it is to 125, right? So it's probably 2.1 or something like that, something really close to 2, because it's just a little bit bigger than 25. But how would you find this number out? Well, if you have a calculator, and even if you have a just basic calculator that you buy at the store somewhere that's got nothing on it but a log button, chances are it doesn't have log base 5 on the front. Let me pull out, let me get my real calculator so I can do something. Boy, is that thing just crazy looking. Okay, so in this particular case, if you have a TI-83, right here in the front it says the word log. But what base is that? When there's no log written base there, it's understood to be 10. And if I'm trying to do log base 5, what good is log base 10? Right? I want to know 5 raised to the power, not 10 raised to the power, except if I use the change of base formula where I can choose my b, what am I going to choose?
10.
Because that's the one I have. Does that make sense? So I'm choosing it because it's the one. I can choose any one I want to. I can also use the natural log too because it's also base e, right? But I can choose whatever I want to. So if you have a basic calculator that has a log on it, you can do any log you want to. You just have to do, look, log of the top number, which is 30, to close the parentheses, divide by log of the bottom number, which is 5. And we'll see, this one will turn out to be somewhere 2 point something because it's bigger than 2, right? Because 2 would get me to 25. 5 squared is 25, we're trying to get to 30. And 5 cubed is 125, so it's gotta be closer to 2 because 30 is way far away from 125, right? Does that make sense? So let's see what it is on this calculator. You have log, what's the top number again, 30? Close that, divide by log of the bottom number, which is 5, and this will mimic the same thing as doing log base 5 of 30. Because I get to use this change of base where I'm choosing the b to be 10. Does that make sense? And so I should see here 2.1 something, that's like I thought, closer to 2 because again, we rationalize that in our mind, that's no surprise. Now, if you have a nice 84 though, of course you always have an advantage with those, right? Check this out. Oh yeah, just a minute while it loads. I can't believe how long this thing takes to load. I should come in here early in the morning and start this. Okay, so if you have an 84, do yourself a favor, hit alpha and then window. See if that pops up. Yep, and then go down to the one that says log base number 5. And if you hit this on number 5, look at that.
Oh,
Now I can put in 5 and 30 without having to do the change of base formula because all the calculator is doing the change of base formula for me. So cool, lucky for the 84 people to do that, but was it really hard what I did? I did log 30 divided by log 5. I mean, there's not much more of it, right? You can do the same thing on the 83. It just doesn't look quite as pretty. Right? This kind of looks cool. Admittedly, it does, right? You guys don't get excited about things like that, I do. But if you look at my 83 right here, it wasn't that hard to write this either, right? You see that there's no change in the answer, and this was not difficult to write. And it does teach you to change the base formula because you have to use it. That's why this formula is good. But that's the only place where we're going to use a change of base formula for now. What we're going to do here is go back to this homework, and you can see the first thing I'm going to do is I'm going to write this is not correct, but just watch. Log base 5 of 25, and then plus log base 5 of x. Now that is correct because using property number 1, and this says, and I can write it bigger so everybody can see, log base 5 of 25x. That's being multiplied in there, right? The 25 times the x is being multiplied, so it's this one right here. So you see how I busted it up into two separate with a plus sign? Now what's the problem is though, what is log base 5 of 25? 5 to what power is 25? 2. So this is just 2. So I can't leave it as log base 5 of 25, it's just 2. So if I do this, it's going to say, although your answer is correct, it's not in the proper form type thing. Here, I'll show you. I know it's going to say that, so don't be shocked when it does. It's going to say, although your answer is correct, see, it's just in the wrong form. I have to go change that log base 5 of 25 to what it is, which is 2. Okay? So, let me fix that. That's just 2. Okay, can I answer any questions at this point? Let's make it visible for everybody. I know it's really difficult to see. Okay, this says log base 6 of z to the 3rd power And whenever you have powers, I call them exponents, they sometimes call them powers, right? Powers. If it says express powers as factors, this right here is the Pearson language for property number 3. My 3, it's not like 3 in the world, but the third one I put on. We're gonna call those 1, 2, and 3 in our class, and 4, and they're gonna stay that way for the rest of the class, but of course, if you open a book, I mean, it could be in any order, right? You know what I mean? But for our class, we're gonna call them properties 1, 2, and 3. So this is the way Pearson tells you to use property 3. And property 3 would take this 3 and do what?
Put it up front.
Just move it out front, that's all you do. So instead of writing log base 6 of z cubed, you're gonna write 3 log base 6 of z. Okay? Kind of not too hard, really, but you would never know to do that if you didn't know the property. So, and that does seem kind of strange that you can get away with that, and it's really helpful in math that you can. The bottom line was at 6, and then z over here. It should work. Let's see. Okay, so now we're back to property number 1. That says the ln of e to the e times x. And it does say this too, although I don't think we have to worry about that. That would be the ln of e plus the ln of x, right, using property number 1. So we're doing some mental math here for a second. What is the ln of e?
Log.
What is it?
Log. I don't know.
So we're going to write this as the ln of e plus the ln of x, right? Because the property number 1 over here, 2 things being multiplied gets separated by plus signs. Everybody good with that? What do you think this is?
1.
It is 1. Now think about why it's 1. What does ln stand for again?
E.
Log base e, right? Log base e of e is asking what exponent do you raise e to get e itself? 1, right? So the ln of e is 1. E to what power equals e? 1. Does that make sense? Okay. So I can't write that as the ln of e here. I have to write it as 1, because if I don't, it'll say, although your answer is correct, it's the wrong form. So I have to do that and then just type ln x. And we are good. Okay, so I'm going to do this one with pen here in a second, but we're going to try to use our minds also. So when you have 2 things being multiplied right here, property 1 says we can do what? Spread them out as 2 pluses, right? Property 1 says plus. And property 3 says we can take these exponents and do what?
Put them up front.
Move them to the front. That's what this means right here. That's what this whole statement is. So we're watching for that. So do you think you can go straight to the answer right now? I'm going to write it. See if you can do this with me. Because I know I'm going to break them up with a plus sign, and then I'm going to use property 3. This 2 is going to go out front, log base c of the u, plus the 9 is going to go out front, and the next one, log base c of v. Now that's jumping right to the end. What I really did there was this. I did log base c of u squared plus log base c of v to the 9th, because they're being multiplied. Property number 1 says I can split them into plus signs. So that's the first step. And then the second step, this means to do what? Take these numbers and put them out front. But you see how I did that all in one step? Because I just separated and put the numbers out. You can do that, right? You can multitask like that. Yeah, but it probably is good to start by doing it the proper way, right? Which is to separate it with plus signs. This is step 1. And then step 2 is to take these numbers and put them out front because of property number 3. And that's what this is saying right here. This is saying use property 3. That's what it's saying in English. Well, in our class it's property 3. And I don't know what property comes in the book, but in our class that's saying use what I call property 3. Make sense? So the more you practice these, the less weirder they get. Let's see if I can do this. 2 log base C of U, and then plus 9 base C of B. So a lot of these logs, there's some things about logs that we know that, first of all, what number is down here, which in this case there isn't one, so I'm gonna write a 10 just to show you. Whenever there's no base, it's called a base 10. So the one, this is called the base, right? And the base is always a positive number. And not equal to 1, 2. And what do we know about the inside of a log here? Remember what I called it? Anybody remember? It's a strange name. Sounds like you're fighting with somebody. It's called the argument. I said that the other day, remember? Okay, maybe you don't. So this is the argument. What do we know about the argument? Also has to be positive. So what they do here is they write this x greater than 0 to make sure that they're stating the domain. But as far as our work is concerned, just ignore this. It's true, x has to remain greater than 0, but just ignore it for our work. So don't freak out, you don't have to do a thing with it. Might as well not even be there for what we're about to do. Okay, what we're about to do is take anything that's on the top is going to get a plus sign, and any factors on the bottom,
Sorry.
it's okay, on the bottom get a what? Minus sign, okay? So watch how I write this. Now, I'm going to take a 2-step thing here, but I'm going to rewrite this as log of x plus log of x plus 5 subtract log of x plus 2 raised to the 13th power. So there's an invisible plus sign in front of us, right? You don't write plus to start an equation or an expression now. It's assumed to be positive, but I'm going to put it there for emphasis right now. Don't write a plus sign to start this, right? That's not there. It's assumed to be positive unless you write negative, right? So, you know, when I write x, that's positive, right? I don't have to write this in front of it. You know it's positive. So, but I want you to see that this part was on the top, right? That's why it has a positive sign. This part was on the top, so it has a positive sign. This part was where? So that's why there's a negative sign. And I'd almost be done. I have written it as a summary. I've actually answered the first question. But then there's the last statement. What's that say to do?
Move to 13.
So now I have to take any exponent, so there's only one. This 13 needs to go where? In front of the log, so it goes right here because of this. That says use property 3. So you see how I did that now? Top gets a plus, top gets a plus, bottom gets a minus, and then I put the 13 out front because of the express powers of factors.
Is there a reason we didn't distribute the x on the x plus 5?
Well, then it would no longer be multiplication, and I couldn't separate them, because this only has separation if it's being what? Multiplied, not added in here. If you have a log of things being added, you can't break it up. So if we would have distributed the x, we would have blown everything. Make sense?
Yeah.
So let's see if we can write this out. Write in there for log of x. I like when they use log base 10 also, because I don't have to like do subscript. Plus log x plus 5, is that right? And now I'm going to subtract and put the 13 out front. Log, and what was it, x plus 2, I think?
Mhm.
And then, you know, cross your fingers, right? 'Cause we- Oh, if I can do that. Okay, Eduardo, see how this thing is now pluses and minuses up here? We'd rather see it as what? multiplication, because then I can break it up. So is there any way I can write that as two binomials being multiplied together? In other words, is there any way I can change x squared minus x minus 6 into two binomials? Wouldn't that be better? Because then I could have multiplication and break them apart. What is the answer to that? X here, what two numbers make this happen?
2 and 3.
I would say minus 3 and 2, right? Minus 3 times 2 is negative 6, and minus 3 plus 2 is negative 1. So now that if I change this to what's up there, x minus 3 and x plus 2, this is very similar to the last problem. A little trickier though, remember, just ignore this, okay? Don't even look at that, it's not there. But notice the 1/4 can come out in front here now, in front of all of it. Last one, it was just on the bottom one right here. Now we have this one that's on everything. So I'm gonna take this 1/4 and put it out front because of this. That means use property 3. So this 1/4 is going out front. And then at the moment I would have this. I would probably do 2 steps at once if I was doing this myself, but I wanna make sure you guys see this. Okay, so all I did was take that 1/4 and move it out front. Now that 1/4 is gonna stay there, and I'm gonna make myself these long brackets like this, and I'm gonna put the ln, and anything on the top gets a what sign? And anything on the bottom gets a, so this will be ln, that's still positive, I don't have to write a positive in front of that, it's assumed to be positive, and plus ln x plus 2, but then minus ln of x plus 5 to the 5th power. See, because anything on the bottom is going to get a minus sign. I'm almost done, but you see that 5 is still up there, right? And this thing says to do what? Don't leave any exponents like that. So what do I have to do with that 5? This 5 needs to come right out in front of there. And I also need to take this 1/4 and distribute it in. So it's gonna be a 1/4 times this, a 1/4 times that, and a 1/4 times the 5 that's in front would be 5/4. Does that make sense? So the end result would look like this. 1/4 the ln of x minus 3 plus 1/4 of the ln, that's a 4, not a y, ln of x plus 2 minus 5/4 the ln of x plus 5. Why is it 5/4? Because that 5 comes down here, and then the 1/4 hits the 5 and becomes 5 times 1/4, or 5/4. Make sense? A little bit? Because that's the answer. Just takes 20 minutes to write, that's all. What's the first one? X minus?
5. I'm sorry, 3. Wait. Yeah, 3.
Yeah, that's what I thought. Okay, and then plus 1 divided by 4. ln of x plus 2, right? Like I said. And then minus 5/4 the ln of x plus 5. That looks right. Okay, so use Pearson to teach you something here. Let's go back for a second. A few moments ago. There. Take a look at the answer to this one. You see how it says 2 log base c of u plus 9 log base c of v? How did we get that to happen? Well, we first did what? We broke these apart and then took the numbers and put them out front. So what if I gave you this? Could you give me this? What would you do? You would take this 2, put it up here, take this 9, put it back, And then because it's a plus sign, stick them together as multiplication, okay? Isn't that exactly what they're asking us to do right there? So what's the answer? Single log, base 5, u raised to the 8th times v raised to the 6th. It's the exact opposite of that last problem we just did. Is it v and v raised to the 6? Should be it. Okay, so before we go forward, make sure you understand what I did there. I just did the exact reverse of that other problem, right? We started with this in the first problem, we broke it apart and put them out front and got this, so of course going backwards, we just do everything backwards, right? Put numbers back up, stick them back together. So we can go both ways. It's kind of like unpacking a box and packing the box back up again, right? We unpack the box and spread it out, or we can take the spread out stuff and pack it back up into a box, depending on what we want to do.
We
So-
can go over the review for the test.
Yeah.
When is the test?
We can?
Tomorrow.
Test is tomorrow? Yeah, let's do that. As soon as I finish this one problem.
Or we can do the test Wednesday.
This is the only thing you have to remember about these, is that they still throw some other math at you. Remember that the square root of x can be written as x to the 1/2, okay, and that's not part of logs or anything, it's just another part of math that you just have to remember, because now if I do this, I have a subtraction sign right here, right? So that means I can write this as a single log based on property number 2, x to the 1/2 on the top, x to the 5th on the bottom, right? Because minus sign, look at it, like if you have a minus between two log, write it with the m on top and the n on the bottom. So you see how that worked? Just look at property 2. Then we have to realize that, you know, in an easy scenario, y to the 5th over y to the 3rd becomes y to the 2nd, right? 5 minus 3 is 2. Of course, what's 1/2 minus 5? Well, what is 1/2 minus 5? Log base 3 of x to the 1/2 subtract 5. Okay, so that's what? 5 is 10/2, so 1/2 minus 10/2 is negative 9/2. Make sense? Just doing that in my head. Log base 3, I forgot to write a 3, x to the minus 9 over 2. And then, what's this say to do? Take that minus 9 over 2, put it out front. Minus 9 over 2 times log base 3 of x. Okay. And I'll stop there. The next one's pretty mean anyway, so. What do you want to do for the review? Do you got any serious questions on that?
Can I get the review?
Can you?
I do have a copy in my office, but there's also one on Canvas. I put it on Canvas, but I'll get you a hard copy in just a second.
Can you do number 7? I understand how it works. It's just
Yeah.
it takes a while to work out. I feel like there are a lot of places you can mess up with it.
Fair enough. Let me
It's a
go
lot
grab
of
a copy
crunching.
for you. Well, you can just write it, I guess, right here. Number 7, you said?
Yeah. F of x is 20 over x. G of x is negative 8 over x minus 5.
I'm just asking for the domain, right?
Oh,
Yeah.
okay. I know. On the homework, they were having us multiply the whole thing out.
Yep.
Like solving for 4 different ones.
Yeah,
That's
that's the
all right.
ones I was
This
looking
is still, it's still not super easy because,
Oh.
remember
You have to make the
this?
equation.
Okay, this is important to remember for the domain of a composite function, especially they give it to you exactly. That can be written as an f of g of x.
Yes.
Okay, now, first of all, we have to figure out what the composite function is before we can even talk about their domains. In other words, I have to put g of x, what number are we doing, 8?
So,
I have to, oh, 7 you said?
Yeah.
Okay, sorry. 7, so I have to put this one into here.
Yes.
Okay, so you'll get 20 over minus 8 over x minus 5. 20 over minus 8 over x minus 5. Now this is basically the same thing as 20 over 1 divided by minus 8 over x minus 5. And the reason I wrote it this way is because it's what? Keep, change, flip, right? Remember that whole thing? So this becomes 20 times x minus 5 over negative 8. You can do some canceling here, but right now, before I go any further, what's on the bottom of that fraction? Negative 8.
Okay.
Oh, 1, 2, yeah, 1. But we're going to multiply straight across. Negative 8. Is there an x down there?
no,
So do I have any domain issues?
no.
So right now, the domain is minus infinity to infinity. Except whenever you have a composite function, you got to remember that the middle one gets tacked on. And what's the middle one not take?
5.
Negative, oh, wait.
Positive 5.
5.
See? So we can't use positive 5, even though positive 5 fits in here just fine, right? There's no division by 0 when you use 5. This has minus infinity to infinity as its domain, but because it's composite, you always have to throw in this one's part, and this one doesn't take 5, so the only answer should be 5.
Is it not 0, the answer?
Why would it be 0?
Because the first one has an X in the
Yes,
denominator.
this is what I'm trying to say.
So-
This is apparent to this, and when we put this in here, that X went away. It's now a negative
Okay,
8.
yeah.
Okay.
So that's been handled.
Mhm.
But the answer to, if you walked up into this function, I'll go ahead and multiply it out over here. That'd be 20x minus 100 all over negative 8, right? When you distribute the 20 times x into. Okay, what's the domain of this function? All real numbers. There's no division of any x's down here. There's nothing to cause it. So this, if you just walked in the room and saw this, this is definitely minus infinity to infinity, for sure. So why I can't use 5 over here? Well, because when you use composite functions, this one gets included just for fun. It's not just for fun, there's a reason, but you just have to remember. So instead, this is all real numbers except 5.
So you don't have to,
Or you can just say x can't equal to 5, which is much easier to write.
you don't
Would you
have
accept
to,
that?
Yes.
you don't have to plug it in and do all this stuff, right?
You don't have to, no. There's a way around it, yes.
Okay.
Here's how I do it. Okay. This is a trick. I won't show you this in the book, but I take the inside function and I set it equal to the problems of the outside function. What's the problem of the outside function? 0, right? I set g of x equal to 0 and I solve that. So that means minus 8 over x minus 5 equals 0. Multiply both sides by x minus 5 and you'll see that you'll have minus 8 equals to 0, which is a contradiction. There's no solution. In other words, you will have no problems to add. The only thing you have to add is this one right here, minus 5. That's my little super secret shortcut. Let's try it on the next one. Here, actually, let's try it on one that really works better than that. I'm gonna give you an example of one, okay? Why? Example. make it easy. Okay. All right, so if we're looking for the composite function f composite g of x, we could find it by taking g and putting it into this x right here, right? So f composite g, if we did that, we would get 3 over 5 minus x minus 1. Is everybody good with that? Taking that g, putting it into the x of this one, so it'd be 3 over all of that minus 1. Make sense? Then I would multiply the top and bottom here by x, and I get 3x 5 minus x. Okay? And what is the domain of this function? X can't be what?
5,
5. Why can't x be 5?
because it makes it 0.
Right, now notice in the original one here, this one says x can't be 0, and this one says x can't be 1, right? There's no mention of the word number 5 in there. Where does this 5 come from? From this one. But what else do we have to include here? The one on the inside is what? So we also have to be obligatory, put that one in there as well, right? That one, 0 fits in here just fine, but we always have to add the one from the inside, okay? Now, check this out. That's how we do it for real. Now, here's my super secret shortcut, okay? So, here's how I do the shortcut. What's the inside function?
G.
And what's the problems of the outside function?
1.
Where did you get the 1 from? That orange one right up there. F of x can't be 1. So if I set g of x equals to 1, I get 5 over x equals to 1. Multiply both sides by x, and you get what? 5 equals x. There's your domain. I didn't even have to find the composite function, and I got to 5. You see what I mean? Isn't that what this says right here?
Yeah.
It's super secret shortcut. But you have to really understand what you're doing to use it. If you don't understand what I just did, then just find the composite function, put its domain, and then throw in the inside one just for fun.
Okay. So you always have to put
Always have to put the inside one, not the outside one though. Notice there's no 1 over here. But the inside one gets tagged on. You have to tag it on. Okay, so what I did over here as an example is I came up with the actual function, the actual thing, and looked at the domain and said it was 5. Then to demonstrate my secret shortcut, I took the inside function and set it equal to the problems of the outside function. And look how fast I got that number. And I didn't have to do any of this. Because I now know that x can't be 5 and x can't be 0 because that's the obligatory one you always put in. So that's how I do that. Now, I was going to say one of these up here would be good to practice with, but okay, so for this one right here, both these functions have all real numbers as their domain. So no matter what they create, what's their children function going to have?
all my numbers.
So this one's easy. What's the answer for this domain? All real numbers. That was, remember how we did the homework? I kept hitting the button. All real numbers. Oh, shocker. All real numbers. Oh, remember that? Because both of these had all real numbers, so anything they create will have all real numbers. This one's very similar, but watch how this one works. I'm going to set the outside, first of all, the inside function, inside function, because it's inside, has all real numbers as its domain, right? There's no problems here. I'm going to set this thing equal to the problems of this one. This one does have problems. What do we know about the square root?
Okay, be a negative.
Square root of x, right? X therefore must be bigger than or equal to 0 because we don't put negatives. You can put 0 in there, square root of 0 is 0, but we don't put negatives in there. Make sense? So if I want to set the inside function equal to the problem of the outside function, it'd be like this. 5x plus 25 is going to replace that x right there. So it too must be greater than or equal to 0. Then if you subtract 25 from both sides, you get 5x is greater or equal to negative 25. And then divide off to 5, you get x has to be bigger or equal to minus 5. That should be the answer for number 8. You double check that, somebody? It's like magic. Okay. Is there another one anybody would like to see?
The word problems.
Okay, pick one. Didn't I already do this one though? I did this one just on the board, right?
Yeah.
Which of
And
the,
I did this one too, didn't I?
which of the sections do you want us to show work on? Or, wait, don't know if I'm phrasing that right,
You know, I understand. I'm trying to, how about this? It's probably easier to say where you don't have to show work.
okay.
I guess on the ones where you're gonna decide whether the functions are inverses or not, you don't have to show me work because you can kind of reason that out if you wanted to. It turns out here that this one's pretty clear to see for me. I hope you guys can think like this. But if I was to take any number and multiply it by 7, so take a number, multiply it by 7, and then subtract 9 and go, oh, I messed up, I gotta get back to where I started. I would then have to add the 9 back and divide the 7 away, right? And that's not what they're doing here. They added the 7 back and divided by 9. This is wrong.
Can we go over inverse functions? I wasn't here for that.
Sure. So that means that this is not the inverse.
So inverse means they equal each other. Just
If you wanted to do it that way, that means when you take F composite G, you get X, and when you take G composite F, you get X. If that happens, they're inverse functions, but it's pretty obvious that this is not the inverse, because if I take some number, multiply it by 7, and then subtract 9 and go, oops, I messed up, I would have to come and take that number, add 9 back, and divide by the 7 that I did that with, and that is not what's happening here. They tried to make it look like it was by switching the 9 and the 7, but this is wrong. So the answer to this one is no, these are not inverses. Another thing you could do is just find the inverse. Okay, so if you want to find an inverse, you take the f of x and you turn it to y, and you have 7x minus 9. Now switch the x and the y, invert it. So that would be what? X equals 7y minus 9? And then solve it back for y. So I would add 9 to both sides, and then divide off the 7.
So
And that's
the,
exactly what I did here, and that's exactly what they did not do here.
so the g of f is the inverse of the f of g?
No,
No?
no, this function and this function right here, those two blue circle ones are inverses of each other. They're the exact opposite thing. If I take x and I add 9 to it and then divide by 7, I decide I messed up, I'd have to multiply by 7 and then take away the 9. In other words, it's just the opposite thing. Okay, so maybe for you guys it'd be best if you just found the inverses. Why don't I give you a function to find the inverses? Another example.
Yes, please.
Yes. Find an inverse.
So, will that mean that the second one, like number 14, they are inverses?
They are not.
They're not.
They are not. And I'll show you why in a minute.
Okay.
All three of those are no's.
Do you want us to write the actual inverse or just yes or no?
Well, wait till you see the question on the test. It's going to ask you to if they're inverses or not, and you can say no. You can just say no.
Okay.
But if it says to find the inverses, is what you would do. So here, let's take one. Somebody give me a good number to work with here. 4. Thank you. 4 over x minus 3. Okay. Technically, you would say this. F of x equals 4 over x minus 3. And the first step would be to change the f of x to y. Okay? Because that's what it really is anyways. Let me see if I can get a nice bright color so everybody can see. So I would turn f of x to y equals 4 over x minus 3. You had to pick 4, didn't you? My 4's and y's look an awful lot like each other. So I'll try to make my 4's stand out. So there's a y and a 4 there. You see them? So that's all I did was rewrite f of x as y. Now what? So what would be the next line?
The g.
X equals to 4 divided by y minus 3. This is my invert part. In other words, I switched the x and the y's. Now I got to solve this back for y. To do that, I'm going to take that thing and I'm going to multiply both sides by y minus 3. why am I multiplying by y minus 3? Well, it's going to cancel this here, see that? And now I have y times x, or y times x minus 3 times x is equal to 4. I also distributed that x to both of those. Then I'm gonna add 3x to both sides to get y times x is equal to 4 plus 3x. That's a 4, not a y. Trying to make it look more like a 4 if I can. That's making it look worse. Okay, it's not a y. And then divide by x on both sides.
Are you, I'm sorry, in the second step, are you dividing by y minus 3 or multiplying? Multiplying, right?
I multiply, here it is, I multiplied both sides by y
Okay.
minus 3. This is what it looked like before, then I put y minus 3 on either side, and the y minus 3 is canceled here.
I just can't see while you're writing because you're in front of the board.
Ah, that makes sense. And then I have this, I also distributed that x to both pieces there, right? Y times x and minus 3x. And then I added the 3x to the other side and divided off that x, so this is actually the inverse. Now, what you would then do after this is write f inverse of x. Notice that I wrote the minus 1 sign up here. That means inverse. Doesn't mean 1 over f of x like you think it does. It just means inverse is equal to 4 plus 3x all over x. This guy right there. So all I did was take this thing, set it equal to y, because that's what f of x is, it's y, and then switched them, solved it for y, and then called it the inverse. This is just a naming process right here.
Okay, so you swap the x for the y and then solve for y.
Solve for y, and then
Okay.
when you're done
That
now,
makes sense.
well, and technically though, this is why you have to do this, because this is what drives mathematicians crazy. You see this right here? I have 2 definitions of y on the screen. Y is this or y is that. That's impossible. But so this is just borrowing y. So that's why this actually gets taken away and turned into this, so that we don't have 2 y's. Does that make sense?
Yes.
This is different than y. It's the inverse of y, really. Okay, that was fun. So on the test, all you have to do is just find the inverse. And you know, some of them are super easy. This one wasn't because it had a fraction, but some of them can be super easy. Let's take number 14 for example. Start with y equals to x minus 2 squared. That's what it says right there. So then what we're going to do, it says f of x, but I turned it to what? And then what are we going to do with it? Invert it? So just tell me what to write. Okay, now to do this, I'm going to take the square root of both sides. To get rid of that, I get the square root of x is equal to y minus 2. And then add 2 to both sides, you get the square root of x plus 2 is equal to y. So that's the inverse, the square root of x plus 2. What did they write? See, that 2 shouldn't be under there, it should be outside. You see what I mean? That's why this is not the inverse. They almost made it look like it though, didn't they? All they had to do, that one was easy compared to that one, right? This one is, well, pretty much the same thing I did over there. It's almost identical. I had what, 4 over x minus 3, this is 4 over x plus 2, same exact concept. It does not turn out to be this though. This is also an arrow.
Can you walk us through one of the word problems?
Yeah, sure. All right, so for number 15 though, I would start with this, 4 over x plus 2 is y. This is exactly what I did over there. You take this one, swap the x and y, so x equals to 4 over y plus 2. Is everybody good with what I just did there? Okay, just flipped them, inverted them. Now I'm going to multiply both sides by y plus 2 to get that to cancel. And at the same time now I can distribute this x. So what's y times x? Well, it's y times x. And then plus 2x is equal to 4, right? And then take that 2x and throw it over there. So y times x equals to 4 minus 2x. Is everybody good with that? I'm just subtracting 2x from both sides. and then divide off this, x. That's gone, this is now the inverse of 4 minus 2x all over x. And they got it pretty close here, but what's wrong? Plus sign, it should be what? Subtraction.
Do you have to distribute the x every time, or can you just?
You can, however you can solve for y, you're welcome to do so, but that's what I do. How else would you do it though? Cause,
You divide by x.
divide by x and subtract two, so you get y equals to 4 over x minus 2, yeah, that works, because if you then put an x here and x here as a common denominator, you get 4 minus 2x over x is what I got to, yeah, that works, works just fine. I like to keep things as a single fraction, but if you wanna do it that way, I can read that, that's fine too. Okay, which word problem do you wanna do? Number 3. Was that the one about the bridge?
Yeah.
Yeah.
No. The other two aren't really word problems. Well, the first one is the same as the one we did before, about the putting a fence, it's just on a street, not a river, right? So we did that one. You know how to do that one?
I'm just kind of having a hard time like interpreting how to make the
Equation.
equation.
Yeah.
Okay, let me do that number 1 first real fast, because it takes just a second. And here's what it looks like. We have a street like this, and then we have some fence coming off it. Is everybody good with that part? And how much fence does it remind me? 350 or something like that?
312.
312. So we have the fence, 312 feet. So we have an X here, and a Y here, and no Y here because it's on the street. Does that make sense? So how much fence do we have? We have 2 X's and 1 Y is going to be all of my fence. Does that make sense? Then subtract 2 X's, I get Y equals to 312 minus 2X. I just subtracted the 2X to the other side. That means this part is 312 minus 2X, and this of course is X. And we all know how to find the area of a rectangle. How do you find this red area again? It's the base times the height. Agreed? So read me that equation. It would be 312 minus 2x times x. Distribute the x, 312x minus 2x squared. Perhaps rewrite it in its proper order so you don't mess up the a, b term. And if we're looking for the maximum, minus b over 2a, right? Put back into the function. We've done that before. That's that whole minus b over 2a for the IZE, and then the f of minus b over 2a for anything that ends in MUM.
I'm
Remember that?
good once it's set up, I'm good from there. I just
Right,
need
because
to
then it's
figure out
minus
the
b over
symbol.
2a plugged back into this. And I think you can take it from there. What's it, somebody plug here. Minus 312 divided by 2 times minus 2.
78.
78, when you put it into the calculator. So that means this right here is 78. And then 312 minus 2 times 78, what is that? 144, something like that? No, 156. 156. What is 312 minus 2 times 78? Do you mind doing the calculator?
So 312 what?
312
Two.
minus 2 times 78.
156.
Okay, 156. Okay, so this length is 156, this height is 78. All you had to do is put the 78 back into here. But if you want to see it with your own 2 eyes, if you put it here, how far is this Y right here? 156. How high is it? What's the area of that rectangle? This times that, right? Whatever that is the answer. Okay, let's do that last problem. There. Oh, the suspension bridge. I'm gonna need my. Graph paper to make this look better. Okay. All So, from my suspension bridge problem here, I'm gonna write down the important stuff from the word problem. Write that first. Okay, so we have, the suspension bridge has twin towers that are 1,300 feet apart. Okay, so two towers, 1,300 apart. Each tower is 180 feet high. Okay. The cables are parabolic in shape, U function, and suspended from the top of the towers. The cable touches the surface of the center of the bridge, okay? Question, how high is it 200 feet from the center? Okay, so I just wrote down some notes, is basically what I did, okay? So I got my two towers, they're 1,300 feet apart, each tower is 180 feet high. They're parabolic, it touches in the center, and they want to know what the height is at 200 feet from center. So the reason I did that is because now I need to go kind of draw something here. Okay, so this is not, don't draw this. I'm gonna do it wrong first on purpose. One way to do it would be make a 180-foot tower here and another 180-foot tower here. Make this 1,300 feet in between them, and then run a cable so it hits the center right there somewhere. I really messed that up, but somewhere in the center right here. And that means that we would have the vertex of a parabola way over here, which is fine. But if you had your choice of vertexes, what's a really good vertex for a parabola? 0, 0. Why? Because 0 is a great number to work with in math, isn't it? It's the easiest number ever to multiply and add. So don't do that. Let's make this vertex right here be where the cable hits the road, which means that the towers have to go how far each way? 650, because that makes what? Does that make sense? So I'm gonna go 100, 200, 300, 400, 500, 650. That's why I use 2 as a 100 so I could have a nice 50. Make sense?
Mm-hmm.
100, 200, 300, 400, 500, 650. And then 100, that'd be 200, so 180 would be about right there. There's my first tower. Now, 100, 200, 300, 400, 500, 650. 180 is about right there is my second tower. This is 1,300 feet apart from here to there because it's 650 each way. So first note is satisfied. These are 180 feet high. Satisfied. Parabolic touches in the center. Okay, not the best drawing, but you get the idea, right? I'm a terrible artist, but this is now the vertex. What's the equation of a parabola? Again, we did this. It's what? Y equals a times x minus h squared plus k. You should know that. We've done this. And since we were smart enough to make h and k both what? 0 and 0, this becomes y equals a times x minus nothing squared plus nothing, or just y equals ax squared. Now, if only we had a point that we could put in here to find out what a is. Can you name one point on that graph? 650 and 180. You put 650 in for x, you get what out for y? So put 650 in here and 180 out here. 180 is equal to a times 650 squared. Now I can solve for a. It's going to be a really small number. But take your calculator and divide. A is equal to 180 divided by 650. It's gonna be a number that's gonna have an E on the end of it because it's gonna be, it's gonna give it to you in scientific notation, so just leave it alone on your calculator. Tell me, somebody do it, tell me what you get though. Should be like minus 1 point something raised to the 10, what did you get it? No.
Yeah.
It's the-
What is it?
Awesome, awesome. Is that it?
Yeah, 4.26, did you guys get that? But that's times 10 to the negative 4. That means it's 0.0000, but just leave it just like that, because what we do with this number is we put it where? Right there? Now what's the question asked?
How high would you
So in other words, when x equals to 200, right? You already have A on the screen, don't try to write it down, just multiply it times 200 squared and you have your answer. Just hit times, and then 200, put a square on it, and you should get 17. Did you see? Did you get it? That's how you do it.
Okay, so
Yeah,
the A value is
I did
180,
so
right?
wrong.
What's that?
The A value is 180, right?
No, the A value is 180
Oh,
divided by
okay.
650 squared, which is
Okay. I
point
see.
zero, I think it's positive, 0.0004. But whatever it is, just leave it right on your screen, because it goes where? Right here.
Yeah.
And
then
to
the X
find the
value is
Y,
200.
what X do they want to know about?
200.
So put 200 squared times that number you just got, and it's all over. Make sense? Simple. I think we're past time.
We're at time.
Mm-hmm.
Oh, we're right at time. Yeah, clock lies, doesn't it? Everything